Welcome to the Nordic Venture Show, your speed date with the hottest Nordic innovations and ventures. In this episode, our venture date is with DataCrunch.
Hey everyone, welcome back. You know why you're here. You want to stay ahead of the curve when it comes to AI and the computing power behind it.
That's right. And today, we're zeroing in on DataCrunch. They're making some serious moves in AI cloud infrastructure. We've been digging into their blog posts, news announcements, and guides. Lots to unpack.
It is, yeah. We're going to sift through it all and try to understand what's really going on and why it matters for the bigger picture.
Exactly. Consider this your cheat sheet to DataCrunch's strategy.
Okay, so one thing that keeps popping up is this whole NVIDIA Blackwell clusters available soon thing. And right alongside it, they're urging people to pre-order GB200 NVL72. Seems like a big deal to them.
It is, definitely. They're really pushing those pre-orders for the GB200 NVL72. And if you look at their page on GPU instances and serverless inference, it starts to make more sense. This GB200 NVL72, it's not just a bunch of separate processors thrown together. It's designed as this super integrated powerhouse.
So break it down for us. What's so special about this GB200 NVL72?
All right, so at its heart, you have a single cluster, and it's a beast. It combines 36 of those cutting-edge NVIDIA Grace Blackwell superchips.
Wow.
Which means you have a total of 72 GPUs all working together. But here's the real kicker. The way these GPUs talk to each other, it's a huge upgrade.
Yeah, I remember something about the interconnectivity being a big selling point.
You got it. Before, they often used things like InfiniBand to connect the GPUs. But with this GB200 NVL72, all 72 GPUs can talk directly to each other. They use NVIDIA's NVLINK technology, and it's blazing fast, 1,800 gigabytes per second. That's a major leap.
So instead of the data having to go through some middleman, like with InfiniBand, each of these 72 GPUs has a direct high-speed connection to every other GPU in the cluster.
Exactly. Think of it as this unified NVLINK domain. Any B200 GPU within the GB200 NVL72 can access any other B200 in the system directly. DataCrunch is saying this is the start of a new era in AI supercomputing. And when you consider the challenges of getting all these GPUs to work together smoothly on those massive AI models, this direct connection is huge. It could really speed up the training of those huge models.
It sounds like they're betting big on this improved interconnectivity. And that constant fill out the form to pre-order thing really shows how much they're prioritizing this strategy.
Definitely. It shows they really believe in the performance gains this architecture offers, especially for those really heavy AI workloads.
Okay, let's switch gears a bit and see what else they've been talking about. Their blog is pretty active.
Yeah, their blog gives us a good look at their technical priorities. The newest technical analyses post is from March 12, 2025, titled DeepSeek plus SGLang, Multi-Head Latent Attention.
Sounds pretty cutting edge. What does that tell us about their focus?
It looks like they're actively working with and incorporating some advanced techniques in large language models. They mentioned DeepSeek, which is a well-known model, and SGLang, which is all about structured generation. So it seems like they're trying to optimize how these models process and generate information, probably aiming to make them both more efficient and produce better output.
Interesting. And right before that, at the end of February 2025, there's another technical analyses post about multi-data center training, prime intellect.
That's right. This one probably dives into the challenges and possible solutions for scaling AI model training across multiple data centers that are geographically separated. As AI models get bigger and bigger and the data sets used to train them become more massive, figuring out how to efficiently spread out that training process becomes super important. Prime intellect might be a project name or a specific method they're looking into.
So it's not just about brute hardware force, it's also about the sophisticated software and distributed systems needed to make the most of all that power. Makes sense. Now, what if we rewind a bit and look back at some of their blog activity from 2024 and the start of 2025? Anything jump out at you?
Let's see. Going through their posts, there's a technical analyses piece about deploying the massive DeepSeek R16701B model on a cluster of 8 NVIDIA H200 GPUs, and they're using SGLang there too. This shows they have experience in actually deploying and optimizing these demanding AI models on their existing infrastructure.
And they also have a guides entry from January 31, 2025, all about DeepSeek v3 LLM NVIDIA H200 GPU inference benchmarking.
Exactly. This tells us they're not just thinking about the training phase, but also about inference, which is how efficiently those big models can actually generate predictions or answers once they've been trained. They're doing benchmarks on specific hardware, like the H200 GPUs, which means they can give their users valuable performance data if they need to deploy those models.
There's also a benchmarks post from January 9, 2025 that gives a cloud GPU pricing comparison in 2025. Understanding the cost is always crucial when using cloud resources.
Absolutely. The cost effectiveness of different GPU offerings is a big factor for users. That post probably compares DataCrunch's pricing with their competitors, maybe highlighting areas where they offer better value.
And it wasn't all just super technical stuff. They also had some interesting news announcements.
Yeah, a couple of big ones. In December 2024, they announced that DataCrunch leads Europe in deploying NVIDIA's new H200 GPUs. That kind of announcement gets them good press and establishes them as a leader in adopting the latest hardware.
It definitely puts them on the map as a major player in the European AI infrastructure scene. And there was news about funding back in November 2024.
Right. They secured a hefty $13 million seed round to, as they put it, transform AI computing. That kind of investment can really help them expand their infrastructure, do more research and development, and offer a wider range of services.
That shows a lot of faith in their vision and potential. There's also a more basic news piece from October 2024 that explains what are CUDA cores, example and differences with tensor cores.
I think that's aimed at a wider audience. Maybe people who get the idea of AI but want to understand more about the actual GPU architecture. By explaining the difference between CDA and tensor cores, they're helping to make the technology behind AI a little less mysterious.
And earlier in the year, July 2024, there's a news item comparing PCIe and SXM5 interconnects for NVIDIA H100 GPUs.
Yeah, that probably went into the different ways to connect GPUs within a server and how those choices affect performance. For users who really want to get the most out of their hardware for specific AI workloads, understanding those interconnect options is key.
So their blog has a really good mix of content, deep technical dives, more accessible explanations of core concepts, and important company updates. Now let's talk about the services DataCrunch actually offers based on their GPU instances and serverless inference page.
They have three main categories. First up, GPU instances. This is where users can rent individual GPUs on demand or through longer-term commitments.
Seems like a pretty standard cloud computing model for GPUs.
Yeah, pretty much. It gives users a lot of flexibility depending on how long their project is and what kind of resources they need.
What are the other options?
Next, they have GPU clusters. This takes it up a notch. It's like a custom-built, fully managed set of interconnected GPUs. And importantly, these clusters come with their own custom software stack. That can be a huge plus for users who need that high-performance parallel computing, but don't want to deal with the hassle of setting up and managing all the underlying infrastructure themselves.
So it's for users who need serious computational power and interconnected GPUs, but they want a simpler solution. And the third category.
That's serverless inference. This is all about deploying trained AI models so they can generate predictions or insights. It's super scalable and cost-effective. The whole serverless thing means users don't have to worry about the servers themselves. The service automatically adjusts based on demand and usually pay per use. It's great for applications where the demand for those AI predictions can go up and down a lot.
Sounds perfect for applications that need quick deployment and the ability to handle changing usage levels without having to pre-allocate resources. Okay, going back to the GPU instances, they highlight a specific configuration, the H200 SXM5 instance. What are the main specs?
So this one has a single NVIDIA H200 SXM5 GPU, and it's a powerhouse. It comes with 141 gigabytes of GPU RAM. On top of that, the instance has 44 CPU cores and 185 gigabytes of system RAM. That SXM5 means it has a high bandwidth direct connection interface for the GPU, which is great for those really demanding workloads.
And they actually tell you what kind of tasks this setup is best for.
They do. They list the best use cases as gargantuan ML models, multi-GPU training, FP64 HPC, and NVLINK workloads. FP64 HPC is double precision, floating point, high performance computing. It's like the highest level of accuracy you can get for complex calculations, usually needed for scientific simulations and advanced research. And seeing NVLINK mentioned here, even for a single GPU instance, could mean they support connecting multiple instances together with high bandwidth.
What about the cost? Cloud GPU pricing can get confusing.
Again, they give an example of an hourly pricing model where the rate goes down the longer you commit. They also have price-on-demand options, which they say can save you money through dynamic pricing. It'd be interesting to dig deeper into how that dynamic pricing works, how much the costs actually fluctuate.
Yeah, it seems like they're encouraging longer usage with lower rates and offering more flexible, potentially cheaper access through dynamic pricing. One other thing I saw on their services page is the claim that all infrastructure powered by renewable energy. That's a big deal for a lot of people nowadays.
Definitely. For people and organizations who are all about sustainability and minimizing their environmental impact, that's a strong selling point. It's in line with that whole green computing movement.
Totally. Okay, big picture now. Looking at everything we've covered, what are the key things DataCrunch is emphasizing? What benefits do they want potential users to take away?
There are a few things that keep coming up. First, they talk about fast, dedicated hardware. That means high performance and reliable access to powerful computing resources. Then they emphasize productivity. They offer features like instantly starting, stopping, and hibernating instances through their dashboard or their API, which makes things a lot easier for users.
So a smooth and efficient user experience is important to them.
Definitely. They also highlight expert support. You can chat directly with their engineers, which is super helpful when you're dealing with tricky technical challenges in AI. Security is another big one. They're ISO 27001 certified. And lastly, they make it clear that signing up is easy, and you can pay as you go. They're trying to make their services accessible for everyone, from individual researchers to big companies.
All right, we've covered a lot of ground here. Their upcoming Blackwell clusters, the advancements in GPU interconnectivity, their range of services, and what we can learn from their blog. What's the main takeaway for our listeners?
The big takeaway is that DataCrunch is seriously positioning themselves as a major force in AI computing infrastructure. They're getting ready for the launch of those NVIDIA Blackwell GB200 NVL72 clusters, and the way they're emphasizing those improvements in interconnectivity through NVLINK shows that they're ready to handle the most demanding high-performance AI tasks.
And it's not just about having the newest, most powerful hardware. They're building a whole suite of services to fit different needs, from those individual GPU instances for smaller projects to fully managed clusters for large-scale training, and that super scalable serverless inference for deploying models in the real world.
Exactly. It's a whole ecosystem designed to support every stage of AI development and deployment.
So as we wrap up this deep dive into DataCrunch, here's something to think about. With these rapid advancements in AI computing infrastructure, especially with systems like the Blackwell GB200 NVL72 and all that power and interconnectedness, how could this fundamentally change the kinds of AI research and applications that are possible? What new doors could open in fields like scientific discovery, complex simulations, or even in creating entirely new kinds of AI once these computational resources become more readily available? Think about it.
Thanks for listening to the Nordic Venture Show. Don't forget to subscribe and stay tuned for more stories of innovation from the Nordics.